Welcome to Konko Academy. In this tutorial, I'll still be taking you guys through some concepts of limits. We will be doing infinite limits, and also I'll explain some ways of solving piecewise function limits, and also I'll go over the right hand side and left hand side limits. If you are new to this channel, I recommend that you please subscribe to our channel and put us on post notifications so you'll be notified whenever we upload a video. Now, for a limit to exist, for a limit of a function to exist, the right hand side limit, that is the limit of it as it approaches that particular value from the positive direction. So if you are approaching from the positive direction, it is the right hand side limit. That is when you are approaching, let's say this is the limit of that particular function and you are approaching from this value. So from the positive is the right hand side. Now when you are approaching from the negative direction, it is the left hand side limit. What do we mean by that? I've already explained that in the previous video, but I will explain that here as well because students didn't really get it. Now let's say you are asked to find the limit of gain of x or gain of y as y approaches let's say 2. Now if I say what you need to do is that for you to confirm that indeed that limit exists, when you put y, right, when you take values of y that is greater than 2, right, and you put it in the function, it will approach a particular value. Then when you take values of y which is slightly less than 2, but they should be close, right, and you put it in that same function, and that function approaches that same value that when you took values greater than 2 it approached, then the limit of that function exists. So let's say we take values from the right hand side of 2, then we take values from the left hand side of 2. So values from the right hand side of 2 can be maybe 2.1, 2.2, maybe 2.001, right? Then values from the left hand side can be 1.9, 1.89, right? 1.999. They should be close. You get it? They should be close. So if you take these values, then we evaluate that function g of y at 2.1, 2.2, and 2.001, and we get, let's say, b, right? Then we do same for the left hand side and we also get b. Then the limit of that function exists. But let's say when we did it, we had for the right hand side to be b and for the left hand side to be c. Then the limit of that function does not exist. Now let's move on to our real concepts. Now say we are asked to find the limit of this function g of y. We are asked to find the limit of g of y. So g of y is a piecewise function. Now let me explain the concept of piecewise function. Piecewise function is normally made up of conditions and a function, right? Conditions and a function. This means that when the value of y that is given, right, is less than -2. So let's say when I give you y equal to -1, y equal to 0, y equals to -10, you should put or evaluate the function with this expression, But when I give you values of y greater than -2 or equal to -2, so let's say -1, 0, 2, 4, 6, 8, then we use this function. Sorry for this, I said -1. I'm really sorry. So when I give you functions like or values of y like -3, I'm really sorry, -4, -5, then we use this function. But when I give you values like -1, 0, 1, 2 are going, then we use this function. That's how we evaluate a function. So for this function, I'm asked to find the limit as y approaches 6, right? So what we do is that for me to know that this function or this limit really exists, I will approach 6 from the right hand side and also approach 6 from the left hand side. And if they are equal or they are converging at a particular point, then I say yes, the function does exist, right? So for y approaches 6, I'm supposed to use this expression, right? I'm supposed to use this expression. So I'll say g of y, right, is equal to g of y is equal to 1 minus 3y. Now I'm approaching from the positive direction first. So I'll do for 6.1, 6.001 and see the values that I get. So if I do for 6.1, I'm going to get -17.3, right? -17.3. Then I'll do for 6.001. Then I get for 6.001, I get -17.003, right? Now let me approach from the negative x-axis. So if I'm approaching from the negative direction, sorry, I said negative x-axis, negative direction, I'm going to take values that are less than 6. So I'll take 5.9 and also 5.999. So when I take that, I'm going to get -3, 5.9. So for that one, for this, I get -16.7. Then for 0.999, I get -16.997. So we can see that when we approach from the positive direction and the negative direction, we see that we are all approaching a particular number, which is what? 17. And so the limit of this function, right, is equal to 17. And yes, it exists. So this is how to determine the limit of a function and also to determine that the limit of that function exists. When you approach it from the left hand side and approach it from the right hand side, it should converge at a particular direction. And if it doesn't, then it does not exist. Now let's do for y approaches -2 and let's see. So for y approaches -2, it means that we can use this particular portion for values that are less than -2, then y minus 3y for values that are greater than -2. So when we approach from the left hand side, we need to use the upper portion. When we approach from the right hand side, we need to use the lower portion, right? Now we are approaching -2 from the positive direction, and we approach 2 from the negative direction. So if you are approaching from the positive direction, that is this side, right? We need to use this one. So we are going to use -3y. Now if you are approaching from the negative direction, right? So we have to take values like -2.0001, -2.1, -2. Yes. So for that we need to use this, because that's the range that it falls in, right? So that will be y squared plus 5. Y squared plus 5. Okay. So when we do this, let's say we take values like uh sorry, here is negative, sorry. So let's say we take values like um negative 0.1 and -2.1, right? Then we also, for the positive direction, we take values like -1.9 and -1.99, because this is the number line. Let me draw a number line for you to understand the concept very well. Now this equation is valid from this point to this point, and this equation is valid from this point to this point, right? So from this point to this point, I take these values for this point, and I take these values for this point, right? So if that is so, then we evaluate. So now evaluating at the positive direction, -1 minus 3 multiplying -1.9, I'm going to get positive 6.7 for the upper one. This 6.7. Then for 1.99, I get positive 6.97. So it means that it is approaching 7 for that. But for taking it from the negative direction, when I put it in this, I'm going to get 2.01 squared plus 5. I get 9 for the upper one. I get 9.04. And for the lower one, I get 9.4. This shows that these two functions, this function does not have a limit at -2, because they do not converge at a particular point. This is converging at 7, and this is converging at 10, right? So they do not converge at a particular point. This makes so we can conclude that the limit of this function, or the limit of g of y as y approaches -2, does not exist. Now let's move on to infinite limit. So suppose we have a function like 1/0, right? If you have a function of 1/0, the answer is going to give us infinity, right? Infinity. So it can be it can be either plus or minus infinity, depending on where we are considering, right? Good. Now when we are asked to find the limit of a function, as we know, we need to determine whether the limit exists or not, and for it to exist, the right hand side limit should be equal to the left hand side limit, right? So with this, when we put 0 in it, we are going to get infinity. So we don't know whether it is positive or negative infinity, right? Infinity too can be um a limit, right? Sure. So we first approach 0 in from the left hand side, and we approach from the right hand side. So we find the limit of x as it approaches 0 from the right hand side. Then we find the limit of x as it approaches 0 from the left hand side. So approaching 0 from the right hand side, I'll use 0 0.1, 0 0.001, right? Then 0 0.01. Then from the negative and the left hand side, I use negative of what I've done up there, right? So negative of the same thing. So negative of the same thing. So when I put these values in this function, that is 1 over x, and I evaluate from the positive direction, that is from the right hand side, I get for the first one 1 over 0.1, I get 10, I get 10, then 1 over 0.001, I get 1000, then for this I'll get, I think, 100, right? So I can see that as I'm approaching 0 from the right hand side, I'm just increasing. I'm not approaching a particular value. So let's say I should have brought 0.01 here so that you see how it is. So you see 0.001 is more close to 0 than 0.01. So as we are getting more close, so let's say if I make it 0.000, I make here 3 zeros. So if I add this, let's say 0.0001, and I evaluate, I'm going to get 10,000. I'm going to get 10,000. And that means that as I'm approaching 0 more, I'm moving into the positive infinity direction. So 1 over x, as we approach from the positive x, or from the right hand side, gives us positive infinity, because we are moving into positive infinity. Now let's do same for doing for the negative hand side, or approaching from the negative hand side. So if I'm approaching from the negative, the left hand side, it's the same thing. So I put negative 0.1 at this portion. So I'm going to get negative 10, negative 100, right? Negative 1000, negative 10,000. So you see, I'm just moving as I'm getting close to 0. As the x is getting close to 0, I'm just going into the negative infinity direction. So if I approach x in the negative direction, it means that I'm going to negative infinity, right? So this means that since when you approach x in the right hand side, it gives you positive infinity, and when you approach x in the left hand side, it gives you negative infinity, the function does not exist. But if it gave me positive infinity for both of them, like, it will exist. But because it's giving me positive infinity when I approach from the right hand side and negative infinity when I approach from the left hand side, the function does not exist. Thank you for watching this video to the end. Do well to like, comment, and subscribe.